Good morning, students. I talked about the data pre-processing, which is important and necessary step to develop machine learning application in my previous videos. Machine learning with Python part 2 to part 6. This video will continue on that. In this video, we will see how we can perform rescaling to improve the performance of the algorithm. Topics of discussion are rescale data, normalized data, standardized data, binarized data. Let us see one by one. Rescale data. When our data contain features with mixture of scales and even in different measurement units, we resort to rescaling. The rescaling process ensures all numeric features in a dataset become in a common scale. This process is not mandatory for all algorithms, but it might be still nice to apply. Two common rescaling techniques are normalization and standardization. Let us see what is the normalization. The objective of normalization is to change the values of a feature between 0 and 1 without distorting differences in range of values. You should keep in your mind, every data set does not require normalization. Let us take a specific example. Suppose our data set contain two numeric features. One is the salary and next is the year of experience of employee. The salary of employee varies 2 lakh to 30 lakh and year of experience varies from 1 year to 20 years. Here you can see in this data, two features are in very different scales. When we do further analysis, for example, multivariate linear regression, the feature salary will intrinsically influence the result more due to its larger values. But this does not often mean the salary feature is important as a predictor. Therefore, in this scenario, we normalize the data. It is seen that the normalization process does not change the distribution of feature, and due to the reduced standard deviation, the effect of outlier increases in our data set. Therefore, before normalization, it is recommended to handle the outliers in data set. Okay. The commonly used normalization technique is min-max scaling. So let us see how we will normalize our data set with the help of the min-max scaling. The formula is x normalized is x minus x mean upon x minus x max minus x mean. Calculate the normalized value of a feature. Let us take a data set contain only one feature and values of that feature is 20, 75, 34, 55, 63. First we compute the minimum of these values. Here you can say 20 is the minimum values and 75 is the maximum values. Next step, we determine x minus x mean. So 20 minus 20 is 0, 75 minus 20 is 55. This way you can compute the next column. Next column, we determine the x max minus x mean, that is 75 minus 20 is 55. And next column, x normalized is equal to x minus x min upon x max minus x mean. So 0 upon 55 is 0, 55 upon 55 is 1, 14 upon 55 is 0.25. This way you can compute the x normalized values of feature. Here you can see the original values of a feature is 20, 75, 34, 55 and 63, and his normalized value is 0 to all values between 0 and 1, 0, 1, 0.25, 0.64 and 0.7. So this way we can normalize the numeric feature, values of the numeric feature. Next is the standardization. Standardization method is go to scale method unless you have a specific reason to adopt the other techniques for rescaling of data. Standardization process transfer values of a feature to one with mean 0 and standard deviation 1. The outcome of this standardization process is commonly known as Z-score, and Z-score is computed as follows: x minus mu, x is the value of feature, x minus mu upon sigma, where mu is the mean and sigma is the standard deviation. Okay. Let us see how will we calculate the standardized values of a given data set. First step, first we compute the standard deviation. Okay. So here you can see in the first column the values of a feature. First column represents the values of feature 3, 3, 4, 4, 6. Next column the mean of the values. Next column x minus mu, value of a feature minus mean. Okay. Next column is square of the x minus mu. Next column is the sigma x minus mu square. Okay. Now the formula is standard deviation. So there are two standard deviation formula. One is the SSD, sample standard deviation, and this is the population standard deviation. So you have to choose to compute the standard deviation by SSD formula or PSD formula. It depends on your data set. Data set is a sample of the entire data set, or it is an entire data set. Okay, population of the data set. If it is the SSD, then you can use the formula square root of x minus sigma x minus mu square upon n minus 1, where n is the number of points in a feature, values in a feature. Okay, for this data set, SSD is 1.2 and PSD is square root of x minus mu square sigma x minus mu square upon n, and it comes out approximately 1.1. The first step, we determine the standard deviation. So using these two formulas, you can determine the standard deviation. Next is we compute a standard value. First column represents the values of feature, next mean, next column QSD, and you can say sigma PSD. Okay, sigma SSD or sigma PSD. We have already seen how we will determine the sigma SSD and sigma PSD. Next column x minus mu, Next column we determine x minus mu upon sigma SSD. Next column x minus mu upon sigma PSD. Next standard value. If sigma is SSD, values are minus 0.8, minus 0.80001.6. Next is the x standard deviation, standardized value. If sigma is PSD, 0.9, 0.9, minus 0.9, minus 0.9, 0.001.8. Here you can observe when you sum all values in the column x standard deviation, you will get the value 0. Mean 0. Okay. Next is the normalization versus standardization. When we will do normalization and when we do the standardization. Actually, it is very difficult to know whether the scaling, rescaling means the normalization and standardization will improve the performance of the algorithm before applying them. It often can, but not always. Some debate states that it is better to keep data around 0 than between 0 and 1. The literature provides some guidelines when we will do normalization and when we will do the standardization. We adopt the normalization when we do not know the distribution of our data, or when we know the distribution is not Gaussian or a bell curve. Standardization is useful when the algorithm we are using, when machine learning methods we are using, does make some assumption about our data having a Gaussian distribution. Okay. Next, binarize the data. In some situation, we want to keep all values of feature into crisp values, that is 0 or 1. In that situation, we will make our data values into a binary values. Okay. Here, we will choose a threshold value. This threshold value is used to decide which values become 0 or 1. Above the threshold value becomes 1, and below or equal to threshold value, we will change it into the 0. Okay. Next topic is the robust scalar. If our data contain significant number of outliers in this situation, it is recommended to change the values of a feature to a median and a quartile. This robust scalar is used to scale features using statistics that are robust to outliers. And the formula used to change the values in the robust scaling is equal to XRS is X minus X median upon IQR, and IQR is 75% quartile minus 25% quartile. Actually, we subtract the median to all observation and then divide the interquartile difference. Okay. Let us see how will we perform the rescaling techniques in our data set with the help of the Python. First, we import the pandas. Import libraries. Run it. Next step, we create a data frame. Read our data set with the help of the data frame. Name of the file is employee data x. Run it. Okay. Let us see the number of instances attribute. With the help of the save command, 11 instances and 4 attributes. Let us see the all 11 all instances of our data set. These are the instances. Here you can see the first feature is the employee name, second is the salary, next is the year of experience, and next is the position level. Okay. Here you can see the salary and year. These two features are in very different rates. Okay. So now we are normalize our feature salary and year with the help of the min max scalar techniques. Okay. So let us take the features from our data set. First is the salary feature. Next we take the year. Run it. Okay. Now we are making a data set consisting of only two variables, salary and next is the year. Run it. Okay. Normalize the normalized data set with the help of min max scalar. Min max scalar. Okay. For this we import the libraries from sklearn, preprocessing, import min max scalar. Okay, next is the scalar. Min max feature range equal 0 and 1. And it. Now we normalize the value. X normalized scalar dot fit transform X. Okay. Now print X normalized. Here you can see we change all values of feature salary and year between 0 and 1. Okay. Here you can see there is one warning. Actually your values are the integer and now it is converted into the real values. Okay. Next. Here you can see okay. Now we are going to now we are going to normalize fruit data set. Fruit data set. Okay. Just take the data set. Okay. These are the contents of 5 contents of the our fruit data set. Now we are normalize the each numeric features. Okay. For this we have to define the features which we are going to normalize. Features is equal to first feature name is mass, next is width, next is height, next is color score, color score, color score. Okay. df features scalar min max here feature range is the optional value. It is up to you to define or not define. 01 is the default value, but you may change this 01 to 0 to 100. It is up to you. Now X normalized scalar fit transform X. Here you can see that again there is a warning. print x normalized. Here you can see all values of each feature is converted into the 0 and between 0 and 1 you can see it between 0 and 1. Okay. Now let us see what happens. I am going to copy this thing. Okay. Modify this. Let us see what happens. I am removing this feature, mass feature. Okay. Now we are going to standardize this, normalize it. X normalized. X normalized is equal to scalar dot fit transform x okay, print it, print x normalized. Let us see. Okay. Run it, run it, and run it. I think there is some mistake here. Before to this, you have to do one more things. Actually, what I want to okay, this is a missing. Oh, this is missing. Control C. Okay. Now we have taken features only with height and color score. Okay. Now I am adding this. Here. Now run it. Run it. Run it. You can see only the three variables. Actually, what I want to show you here, you can see at this time there is no error. There is no warning. Why it happened? Let us see. At this time we have taken only the real values width, height and color score, and mass is we have at this time we are not taking this mass feature. Therefore, there is no warning. If the values of feature in the real, then this method does not give any warnings. If any one or you can say the all values of features in the integer, then it gives a warning. Okay. You ignore the warnings if the values are in the integer. Okay. Now, next step. Now we are standardize our data set. Okay. standardize data. Again, we take our data set imply read Excel X, run it. Let us take the features salary and next is the year, run it. XDF features, run it. Okay. Now you import the from Rescale preprocessing, import standard scalar, standard scalar. Okay, now scalar, X standardized value, scalar, fit, transform X. Okay, print all values are standardized. Means mean 0 and standard deviation 1. When you compute the mean, you will get approximately 0 or standard deviation 1. Okay. Next is the robust scalar. Let us see how we will change the values of feature into the robust with the help of the robust scaling. Normalize, standardize the values with the help of the robust scalar. Robust scalar. Let us take the import the file scalar preprocessing, import robust scalar, scalar X normalized, scalar the fit transform x. Now we have changed feature, salary, and the year of experience to the standardized value with the help of the robust scalar. Okay. Now let us see binarize the value. Next scaling method is the binarize. Import the file. It is again the make a data frame for fruit data set. Okay. Next feature. Let us take the features. Mass. Next width. Next height. Next color score. Color score. Features. Oh, sorry. Color score is not defined. Okay, sorry. Here is a problem. Error. Color score. Okay. Next features. Okay. Binarize the value. X. There is a spelling mistake. BIN and fit X. And ARIZER dot fit X. Positional argument X. Okay, now. Okay. Now X binarize. This is equal to IZER dot fit transform. Before to this we have to specify. Okay, there is one mistake here. We have to specify the threshold value. Okay, this is the missing threshold value. Threshold is, suppose I am taking here the 4. Fit transform X. Run it. Threshold. No, okay. Okay. What we did here, you can see. Let us see our fruit data set. Here we are changing all features of the fruit data set. Values of all features of fruit data set. If the values are greater than the 4, it becomes to 1. 4 are less than 4 becomes 0. Okay, here you can see. Now, at this place, run it and let us see. Print X bin. Run it. Here you can see. All values greater than 4 becomes 1 and less than the equal to 4 or less than to 4 becomes 0. Here you can see. Okay. Okay. Now come to our presentation. So we have seen in this video how we can perform scaling with the help of the Python. These are the references. Any questions? Thank you very much.